Testing. Testing. All right, Math 0092, we're in Chapter 10, Section 10.3. I just want to review with you, we were defining our real numbers, which we're now working with and continue with in your math career. We defined our real numbers as the set of rational numbers and the set of irrational numbers. And of course, we were able to define our rational numbers and irrational numbers. Rational numbers either terminate or repeat in decimal equivalency, and irrational numbers either neither terminate nor repeat in decimal format. So the question is, when you're presented with a number and you're asked to determine if it's rational or irrational, we have to convert to our equivalency in decimal format to make that final decision. So let's look at some examples. We have 2/3. Well, 2/3 is a rational number. It's in the form of an integer divided by an integer not equal to 0 in the denominator. But let's confirm with our calculator, and I've set my mode out as far as we can, so we have as accurate as possible on your calculator. And I have 2 divided by 3, and I get 0.6666, so that does appear in decimal equivalent form to be repeating. And rational numbers, so to speak, behave. They either terminate or repeat in decimal format. So there's a behavior here. They either terminate or repeat. So yes, this is a rational number. How about a -4/5? -4 divided by 5 in its decimal equivalent is a -0.8. So in decimal format, it is terminating. So yes, it's a rational number. 8.2. Well, 8.2 is in decimal format, and that is 8.2. And it terminates, so in decimal equivalent format, it terminates, so it is a rational number. How about 0.47? 777. Well, again, that's 0.47 in decimal equivalent form. It happened to be given to us in a decimal form, and it either terminates or repeats, so it is a rational number. The square root of 2. On your calculator, you'll need to use your square root symbol. I'm using a TI-83. I'm going to use my second to call the uppercase, if you will, to get the square root symbol of 2. Close with my closed parenthesis and enter. 1.4142. And on my calculator, with my greatest accuracy, it does not appear to be repeating, and it's not terminating, so it's an irrational number. And pi we've already discussed. Pi is that special number on my calculator, second pi, enter. In decimal point format is 3.14159. And you want to remember that pi is an irrational number. It neither terminates nor repeats. And the square root of 13. The square root of 13, close, is 3.6055. On my calculator, once again, it does not appear to be terminating or repeating, so it's irrational. How about the square root of 25? The square root of 25, close, enter, is 5.0. 5.0 terminates, so that is a rational number. So again, in order to determine answer, if a number given to you is rational or irrational, convert to its decimal equivalent and determine if it terminates or repeats. If it terminates or repeats, it's a rational number. In its decimal equivalent form, if it neither terminates nor repeats, it's irrational. I hope that helps. That's likely some new terminology for you. So we'll try to put that together now, understanding our real number system. Well, then in chapter 3, we begin to subtract real numbers. Now, we already have studied addition of real numbers, and we have a set of rules for our addition of real numbers. So the difference, A subtract B, is the number for which A equals B plus C. So if I have 5 subtract 2, then I can check. 5 is equal to 2 plus my answer, and my answer is 3. 5 equals 5. So when we are working with subtraction of real numbers, we want to read our definition. And this is one of the most important definitions in your text. For any real numbers A and B, A subtract B is equal to A plus the opposite of B. It says to subtract, add the opposite or additive inverse of the number being subtracted. This is on page 615. And this is very, very, very important. This is why we make mistakes on tests. Subtraction. We already know how to add, so we're defining subtraction. A subtract B equals A plus. That's addition. But we're going to change the sign of the number that we're subtracting. So in real numbers, when I have A subtract B, it's equal to A change subtraction to addition and add the opposite of the number you're subtracting. So our first example is 2 subtract 6. Our directions say complete subtraction by using addition. We already know how to add sign numbers. So this is subtraction. I'm going to change subtraction to addition and add the opposite of the number I'm subtracting. Now I'm adding, and I already know how to add. Subtract the smaller absolute value from the larger absolute value, and keep the sign of the absolute value, which is larger. For subtract the opposite of 9. We always change subtraction to addition and add the opposite. Change subtraction to addition and add the opposite of the number that I'm subtracting, which is a negative 9. Now I have 4 plus, I have a opposite of 9, which is negative 9. I'm looking for its opposite. The opposite of negative 9 is positive 9. So I'm going to add, and 4 plus 9 is 13. negative 4.2, and I'm going to subtract a negative 3.6. Again, this is subtraction. I always, this is how we have sign control as we're working in more advanced classes. Negative 4.2, I'm going to change subtraction to addition and add the opposite. Okay, I took care of that, but I still have to subtract. I have a negative 3.6. So you copied everything else down the same. Now I'm adding a negative 4.2 plus, I have a negative 3.6. I'm going to add its opposite. The opposite of a negative 3.6 is a positive 3.6. And we already know how to add sign numbers. Take the absolute value, subtract the absolute value of the smaller from the larger, and let's see, we'll get 0.6. And keep the sign of the absolute value, which is larger. And 4.2's absolute value is greater than 3.6, so this will be negative 0.6. Example with fractions, negative 1/2 subtract negative 3/4. This is subtraction, so I'm going to change subtraction to addition and add the opposite of the number that I'm subtracting. The number I'm subtracting is a negative 3/4. So I have a negative 1/2 plus, this is the opposite of a negative 3/4. The opposite of a negative 3/4 would be a positive 3/4. And now, as we recall, whenever we add or subtract fractions, we have to think about the piece of pie, and we need a least common denominator. Looks like our least common denominator is 4. So I'm going to convert negative 1/2 to its equivalent in fourths. I have a negative 1/2. I want it to be in fourths. I'm going to multiply by 2. If I multiply by 2 in the denominator, I have to multiply by 2 in the numerator as another name for 1. And bring everything else down the same. 2 times a negative 1 would be a negative 2 over 2 times 2 is 4 plus 3/4. Now I have my least common denominator, so I can write my numerators all over my least common denominator. And the negative 2 plus 3, that'll be 2 from 3 is 1, and I keep the sign of the positive, so my answer is 1/4. Again, subtraction on page 615 is defined in terms of addition. A subtract B is equal to A plus the opposite of B. Very, 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 very important to subtract, add the opposite or additive inverse of the number being subtracted. We have 3 minus 5. This is subtraction. I always change subtraction to addition and add the opposite. So I have 3, change subtraction to addition, add the opposite, and the number I'm subtracting is 5. Now I'm going to subtract 3 from a negative 5 and get negative 2. (1/8) subtract 7/8. 1/8. This is subtraction. Change subtraction to addition and add the opposite, and the number I'm subtracting is 7/8. I do have common denominators, so I can write my numerators all over the common denominator. And 1 plus a negative 7 is a negative 6 all over 8. And we always look to simplify. It looks like this is even, so 2 goes into the numerator. That'd be 3 times. And 2 goes into the denominator 4 times. And negative 4.6 minus a negative 9.8. And we're using the parentheses to protect the sign of this term. This is the operation of subtraction. So we always change subtraction to addition and add the opposite. Negative 4.6, change subtraction to addition and add the opposite of the number I'm subtracting, 9.8. Negative 4.6, I'm going to add, this is the opposite of negative 9.8. Negative 9.8, I'm looking for the opposite, would be a positive 9.8. Once again, I subtract the smaller absolute value from the larger absolute value. $5.2, and then I fix my sign. I keep the sign whose absolute value is the larger, and 9.8 is positive. So my answer is 5.2. I have 8 subtract a negative 4 minus 2 minus a negative 4 plus 2. Well, the first thing I'm going to do is change subtraction to addition and add the opposite. So here's subtraction. Change subtraction to addition and add the opposite of the number I'm subtracting. Change subtraction to addition and add the opposite of the number I'm subtracting. Change subtraction to addition and add the opposite of the number I'm subtracting, plus 2. Now I have all addition. This is 8 plus the opposite of a negative 4 would be a positive 4, plus a negative 2, plus the opposite of a negative 4 would be a positive 4, plus 2. Adding my positive numbers, I get 12, 16, 17, 18, and plus a negative 2. 18 plus negative 2 is 16. Three-fourths minus a negative 1/12 minus 5/6 minus 2/3. Well, this is working with fractions. I see I have that subtraction going on, so I always change subtraction to addition and add the opposite. 3/4, change subtraction to addition, add the opposite. Change subtraction to addition and add the opposite. Change subtraction to addition and add the opposite. And with fractions, we do have to have, for addition or subtraction, we think about the piece of pie. We need a least common denominator. And let's see, 4 goes into 12, 6 goes into 12, 3 goes into 12, so my least common denominator is 12. So now I'm going to convert to equivalence in 12ths. I have 3/4. I want it to be 12. I have to multiply the denominator by 3, so I'll multiply the numerator by 3. Plus the opposite of, and I have, this is already 12, so I'll just carry that down. Plus I'm going to convert 6 to 12s. I have a negative 5, 6. I want 6 to be 12. That's 2. I'll multiply by 2 in the denominator and the numerator. And thirds. I'm going to convert thirds to 12s. That would be 4 times 3 is 12, so I'll multiply the numerator by 4. 3 times 3 is 9. 3 times 4 is 12, plus, this is a negative. And I have the opposite of 1 over 12, plus 2 times a negative 5 would be a negative 10 over 12, plus, that'd be 4 times a negative 2 is a negative 8. 4 times 3 is 12. Let's clean this up a little bit. 9 twelfths plus the opposite of negative 1. Looking for the opposite of negative 1 twelfth. The opposite of negative 1 twelfth would be a positive 1 twelfth. Plus a negative 10 twelfths plus a negative 8 twelfths. Now I have my least common denominator, so I can write my numerators all over my common denominator. And I can add in the numerator, I have positive 10 plus negative 18 all over 12. A positive 10 plus negative 18 is a negative 8 over 12. I know 2 will go into both. Let's see, 4 will go into both. 4 goes into negative 8, negative 2 times, and 4 goes into 12 3 times for a negative 2/3. This is example 13 on page 616. And reading our story problem. Surface temperatures on Mars vary from a negative 128 degrees Celsius during the polar night to 27 degrees Celsius at the equator at midday when Mars is at the point in its orbit closest to the Sun. Find the difference between the highest value and the lowest value in this temperature range. When we're working with story problems, we like to label. I'm going to label my 27 degrees Celsius, and then I'll label a negative 128 Celsius. So I'm looking for the range, the difference between those two temperatures. So the difference is equal to 27 degrees Celsius, and I'm going to find the difference, 128 degrees Celsius. I'm finding the difference. Remember, that was one of our key words indicating the operation of subtraction. And whenever we subtract, our definition says, change subtraction to addition and add the opposite. I'm subtracting a negative. Sorry about that. I'm finding the difference. So I have 27 degrees Celsius, and I want to find the difference from 128. So this is a negative 128. I'm finding the difference. So I'm going to change the sign of subtraction to addition and add the opposite. And the opposite of a negative 128 is, I have a negative 128. The opposite would be a positive 128. Now I can add 27 degrees Celsius plus 128 degrees Celsius and get 155 degrees Celsius. So the difference in temperatures is 155 degrees. So we're looking at the range Okay, then section 10.4. We're going to multiply real numbers. Now we know that 4 times 5 equals 20, and that was a positive times a positive. We're learning that a negative 4 times a negative 5 is equal to a positive 20. A negative times a negative is positive. And a negative 4 times a positive 5 is going to be a negative 20. Or a positive 4 times a negative 5 will be a negative 20. So a positive times a positive is going to be positive. A negative times a negative is going to be positive. A negative times a positive is going to be negative. And a positive times a negative is going to be negative. On page 623, to multiply two non-zero real numbers, multiply the absolute values. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. So when we're multiplying two numbers, multiply the numbers irregardless of sign. And then if the signs are the same, keep the answer positive. If the signs are different, the answer is negative. So 6 times 3. The signs are the same in multiplication, so my answer is positive. 3 times a negative 5. 3 times 5 is 15. Now fix your sign. If the signs are different, the answer is negative. A negative 5 times 3. Multiply the absolute values of the numbers and we'll get 15. If the signs are different, your answer is negative. 7 times a negative 4. 7 times 4 is 28. Now fix your sign. If the signs are different, your answer is negative. Negative 3 times a negative 4. 3 times 4 is 12. And fix your sign. If the signs are the same, your answer is positive. Negative 1.6 times a negative 2. Negative 1.6 times a negative 2. I get 3.2. Fix your sign. If the signs are the same, your answer is positive. A negative 4/5 times a negative 10/3. Now remember, in multiplication of fractions, it's a piece of cake. You multiply the numerators, you multiply the denominators, and simplify if you can. Well, I have a negative 4 times a negative 10, which would be 40. A negative times a negative is positive. 5 times 3 is 15. Now we know 5 goes into the numerator and the denominator. 5 goes into 40 8 times, and 5 goes into 15 3 times. Negative 8 times 2 times a negative 3. Okay, well, this is all multiplication, so from left to right. A negative 8 times a 2. An 8 times 2 is 16. A negative times a positive is negative, and then copy everything else down the same. 16 times 3 is 48. I have a negative times a negative, so my answer is positive. When the signs are the same, your answer is positive. When the signs are different, your answer is negative. Negative 3 times a negative 2 times a negative 5 times 4. This is all multiplication. So I'm going to multiply from left to right. A negative 3 times a negative 2 is 6, and a negative times a negative is positive. Copy everything else down the same. This is all multiplication, so I'll multiply from left to right. 6 times 5 is 30. Positive times a negative, my answer is negative. Copy everything else down the same. A negative 30 times 4. 4 times 30 is 120. Fix your sign. A negative times a positive, my answer is negative. A negative 1/2 times 8 times a negative 2/3 times a negative 6. Well, this is a negative 1/2 times 8 over 1 times a negative 2 over 3 times a negative 6 over 1. We're changing our whole numbers to their equivalent in fractional form with the numerator and the denominator. This is all multiplication, so I'm going to multiply from left to right. A negative 1 times 8 would be a negative 8, and 2 times 1 is 2. Copy everything else down the same. Don't get in a hurry to do another step. Your calculator doesn't. Your calculator does one step at a time according to the order of precedence, except it does it much faster than you and I. Now 2 goes into negative 8. 2 goes into 8 4 times. 2 times a negative 4 would be negative 8 times a negative 2/3 times a negative 6 over 1. Let's see, this is 4 over 1 now. A negative 2 times a negative 4 would be a positive 8 over 3 times a negative 6 over 1. A positive times a negative is going to be negative. 8 times 6 is 48 over 3 times 1 is 3. 3 does go into 48. 3 goes into 48 16 times, and 3 times a negative 16 would be 48. Negative 16. Remember, in multiplying two real numbers, if the signs are the same, your answer is positive. If the signs are different, the sign is negative. Okay, return to D2L Brightspace for all your details regarding homework, assignments, tests, and due dates. And thank you very much.